Hi everybody, this is Mr. Raed النصيرات. In this video, we will talk about lesson 3.8, implicit differentiation and inverse trigonometric functions from grade 12 advanced term 1. Our learning objectives for this lesson: find derivatives implicitly, use implicit differentiation to find derivatives of inverse trigonometric functions, and solve mathematical and real-life problems using implicit differentiation. We have some keywords in this lesson: implicit differentiation, inverse trigonometric functions. Here we can see in this slide circle with radius of 2 and center 0, 0. Suppose that we want to find the slope of the tangent. We want to find the slope of the tangent to the circle x squared plus y squared equal 4 at the point 1 minus radical 3. So this point is 1 and minus radical 3. So we want to find the slope of the tangent at this point. The equation x squared plus y squared equal 4, it's not a function. Because if I take the vertical line, as I see here, I will cut the curve 2 times, one here and one here. So this is not a function. To find the derivative of y for this equation, I will start by trying to write y as a function of x explicitly. So here y squared equal 4 minus x squared, and y equal plus minus radical 4 minus x squared. That means I have here 2 values of y. The first one is y equal radical 4 minus x squared, and the second one is y equal minus radical 4 minus x squared. If I back to the graph here, the first equation, y equal radical 4 minus x squared, we talk about the upper semicircle, this one, y equal radical 4 minus x squared. And y equal minus radical 4 minus x squared, I talk about the semicircle on the bottom here, which is y equal minus radical 4 minus x squared. Now, the question now, which equation I will use to find the derivative of y? This one or this one? The answer here, I will use the equation of the bottom semicircle, which is y equal minus radical 4 minus x squared, because the tangent line at the point 1 and minus radical 3 is on this semicircle. So I will cancel this one now and work in this one. How can I find the derivative of this? Y equal minus 4 minus x squared to the power 1 over 2. I will use here the chain rule. So y prime y prime equal minus half 4 minus x squared to the power half minus 1, which is minus half, times the derivative of 4 minus x squared, which is minus 2x. So the result here, I will cancel 2 with 2, negative with negative is positive, so it stays on the numerator, and 4 minus x squared will go down with the power 1 over 2, which means radical square root. Now from here, I can find y prime at x equal 1 because I need the slope when x equal 1 here. So the result is 1 over radical 3. This is a slope. Now I will try to use another method to find the derivative of y. I will take the equation again, x squared plus y squared equal 4. I will talk with you before I start my method. What about the y here in the equation? This y, it's a function of x. So y here it's a function of x. So y squared means y of x squared. So if you want to find the derivative respect to x for y squared, it's equal the derivative with respect to x for y of x squared. Which rule can I use to find the derivative here? The rule is chain rule. So the derivative is 2 times y of x to the power 1 times the derivative of y, which is y prime of x. So when I come here and find the derivative of both sides, d by dx for x squared plus y squared equal the derivative of the right side, which is 4. Sorry, this is 4, not y. The derivative for the left side, it's 2x plus derivative of y squared, as I explain here for you, it's 2y prime. And derivative of 4, it's 0. Now, it's easy for you to find y prime. Y prime, or 2y prime, equal negative 2x. If I take 2x to the other side, from this I can write y prime as negative 2x over 2y. 2 with 2 will cancel, so it's negative x for y. Now, what about the slope? The slope is the value of derivative at x equal 1, so it's negative 1 over. What about y? When x equal 1, y equal negative radical 3, so over negative radical 3, so the final result is 1 over radical 3. As you see here, the result is the same. If you use the method to write y as a function of x explicitly, or to find the derivative for the both sides and using the chain rule to find the derivative of the function y here, you will find the same result. The second method, this method here, we named it by implicit differentiation. Implicit differentiation. If you use this method name is implicit differentiation. The question now, when I will use or when I must use the implicit differentiation? If you have an equation, okay, with one or more differentiable function y of x, you must use implicit differentiation as y square, y cube, radical y, sine of y, something like this. In this example, we want to find y prime of x for x squared plus y cube minus 2y equal 3. Then find the equation of the tangent line at the point 2, 1. This equation, as I see here, I have y cube. Also, I have 2y, so I will use implicit differentiation. What about, I will take the derivative d by dx for the left side, which is x squared plus y cube minus 2y equal the derivative of 3. Derivative of the left side, it's 2x plus derivative of y cube. Here I will use the chain rule. So it's 3y squared y prime minus derivative of 2y, it's 2y prime equal derivative of 3, it's 0. All terms which have y prime, it will stay in the left side, and the terms that not have y prime will take it to the right side. So 3y squared y prime minus 2y prime equal negative 2x. After that, I will take y prime as a common factor. So y prime times 3y squared minus 2 equal negative 2x. Then y prime equal negative 2x over 3y squared minus 2. So this is the derivative of y, which is y prime. Now, to find the equation of the tangent line at the point 2 and 1, I will find the slope. The slope is m equal y prime, which is negative 2 times x. X here, it's 2 over 3y squared. So 3 times 1 squared minus 2. So it's negative 4 over 3 minus 2, it's 1. So the result is minus 4. Our slope is negative 4. The tangent line, the tangent, or the equation, sorry, the equation of the tangent line is y minus y1 equal mx minus x1. Y minus y1, it's 1. The slope is negative 4. X minus x1, it's 2. This is the tangent line equation, or I can make more simplify as y equal negative 4 times x, it's negative 4x, negative 4 negative times negative 2, it's a plus 8, and take negative 1 to the right side, which is plus 1. So the final result is y equal negative 4x plus 9. In this example, we want to find the second derivative implicitly. Find y double prime implicitly for y squared plus 2e to the power minus x equals 6. Then find the value of y prime at the point 0, 2. The equation is y square plus 2e to the power negative x equal 6. Derivative for the left side, derivative of y square, it's 2y prime. Don't forget, using chain rule. Derivative for 2e to the power minus x, it's negative 2e to the power negative x, and the derivative of the right side, it's 0. Now I need y double prime. Here I have two ways to find y double prime. You can find y prime explicitly here. After that, find y double prime. Or you can start directly to have the derivative for both sides from here and find y double prime. And I will use this way. So I will find d by dx for the left side, 2y prime minus 2e to the power minus x equal the derivative of the right side derivative of 0. Now, derivative for 2y prime. 2y prime, it's a product between two terms. So I will use the product rule to find the derivative. Derivative of 2y, it's 2y prime times the second term y prime plus the first term 2y times the derivative of y prime. Derivative of y prime, it's y double prime. What about the derivative of negative 2e to the power minus x minus minus? It's plus 2e to the power negative x, and derivative of 0 is 0. Now here, 2y prime, I can write it 2y prime square plus 2y double prime plus 2e to the power negative x equal 0. I need y double prime, so I will take the both term 2y prime square and 2e to the power negative x to the right side. So 2y double prime equal negative 2e to the power negative x minus 2y prime square. Now y double prime equal negative 2e to the power negative x minus 2y prime square over 2y. As you see here, the value of y double prime have a terms of x, terms of y, and also have a term of y prime. This y prime, I must substitute it by the value in x and y. Okay, from where I will back again to this equation and find from it the value of y prime. So 2y prime equal 2e to the power negative x. After that, y prime equal 2e to the power negative x over 2y. This is the value of y prime. I will take this value and put it here. So the value of y double prime equal negative 2e to the power negative x minus 2 times 2e to the power negative x over 2y all over 2y. Now I can make more simplify. For example, I can cancel here 2 with 2. Or I can make it from up from here. Sorry about that. Okay, I will remove this also. Okay, from here, because I have more simplify here, I can cancel 2 with 2. So the result is e to the power negative x over y, and I will put it here. That's it. Okay, now In the question, he asked me about y prime at the point 0 and 2, at x equals 0 and y equal 2. So here directly I will go and replace x by 0 and y by 2. So negative 2 e to the power 0 minus 2 e to the power 0 over y, which is 2 over 2 times y, 2 times 2. So the result is e to the power 0 is 1. So here negative 2. E to the power 0 is 1. 2 over 2 it's 1. So negative 1 over 2 times 2 it's 4. So the final result is negative 3 over 4. The value of y double prime at the point 0 and 2 is negative 3 over 4. Now we will talk about derivatives of the inverse trigonometric functions. The question is, how can I find the derivative of sine inverse x, for example? Y equals sine inverse x. Really, to find the derivative for sine inverse x and other inverse trigonometric functions, we must use implicit differentiation. I will explain one of these for you. I choose here sine inverse x, and you can do the same for others. Y equals sine inverse x if and only if sine y equal x and y it's between negative pi over 2 and pi over 2. I will start from sine y equal x and using implicit differentiation to find y prime. So d by dx for the left side, which is sine y, equal d by dx for the right side, which is x. Derivative of sine y, it's cosine y times the derivative of the y, because here again I must use chain rule because y it's a function of x, so you must times by y prime, the derivative of the angle y, equal derivative of x, it's 1. So y prime equal 1 over cosine y. Now I must find the value of cosine y. Let me take right triangle with angle y. Sine y equal x over 1. So the opposite of y is x and the hypotenuse is 1. What about this side? This side by Pythagoras theorem is radical 1 minus x squared. So what about cosine y? Cosine y is the adjacent over hypotenuse. So is radical 1 minus x squared over 1, which is radical 1 minus x squared. Also, don't forget, cosine here is positive all the time, because when you talk about the interval from minus pi over 2 to pi over 2, we talk about the first quadrant and the fourth quadrant, which is the cosine on it is positive all the time. So here now y prime equal 1 over cosine y, which is radical 1 minus x squared. So d by dx for the function sine inverse x equal 1 over radical 1 minus x squared. Here we have the derivatives of all 6 inverse trigonometric functions, and you as a student you must memorize these rules. Derivative of sine inverse x, it's 1 over radical 1 minus x squared, with x between -1 and 1, because we know before the domain of sine inverse x, which is x between -1 and 1. Derivative of cosine inverse x, -1 over radical 1 minus x squared, with x between -1 and 1. Derivative of tan inverse x is 1 over 1 plus x squared. Derivative of cotan inverse is -1 over 1 plus x squared. And derivative for secant inverse x is 1 over absolute value of x times radical x squared minus 1, with absolute value of x greater than 1. And as you know, that means x greater than 1 or x less than -1. Also, derivative of cosecant inverse x, it's -1 over absolute x times radical x squared minus 1, with absolute x greater than 1. Compute the derivative of each function. Here we have y equal cosine inverse 3x squared. Here I must use a chain rule because the angle is 3x squared. So dy by dx equal derivative of cosine inverse x, it's -1 over radical 1 minus angle square. The angle here, it's a 3x squared, so 3x squared times derivative of a 3x squared, it's 6x. So the final result is -6x over radical 1 minus 3x squared, it's 9x to the power 4. What about derivative of secant inverse x to the power 2? Again, it's chain rule. So dy by dx equal 2 times secant inverse x to the power 1 times derivative of secant inverse x, which is 1 over absolute value of x radical x squared minus 1. Because as we see in the previous slide, the derivative of secant inverse square, it's 1 over absolute x times radical x squared minus 1. So the final result is 2 secant inverse x over absolute x radical x squared minus 1. Here we have a small recap of this lesson. d by dx of the function g of y, this is chain rule, please don't forget, derivative of g times derivative of y, so g prime of y times y prime of x. And here I put for you all inverse trigonometric functions derivatives. You must memorize it to solve your questions in the future. Thank you very much for all.